Hello everyone. My name is Prabhat Singh, and today, uh, as usual, we are going to discuss a problem, fleet code. So today problem is based on binary search. So if you are familiar with binary search, then it's good to go. But if you are not, then in this video, you see a pattern to solve a specific kind of problem from this pattern. So you use this pattern and you solve at least four or five not related but following this pattern question you can solve easily. So let's try then let's go. Let me share my screen. Yeah, yep, we are here. So first let's discuss uh, the problem you say. Let's discuss first what's the return and how we approach. There is an integer nums, okay. So you are getting a key, okay, such that the result in blah blah blah. Given array after the possible rotation and integer return the index if the okay. So without reading it, let me tell you in simple language. Gosh. Okay. So there is a target, okay, and the array isn't sorted, but it's in rotated. Means we are we are not uh, we are not assume that we are getting sorted every 2, 3, 4, 5. Uh, it is not like that. Instead, we are. It is like that. 4, 5, and then 0, 1, 2, 3, 4 means sorry, not 4, means it's in rotated mode. So if I rotate it, so one let me first rotation. 1, 2, 3, 4, 5, 0. Second rotation 2, 3, 1, 2, 3, 4, 5, 0, 1. And the third rotation, you might get an idea now. Two and last. So we are getting like this. We are also got like this, but I assume that array is in this form also. So how we tackle this problem now? So I tell you, you might think a solution. That is good, but not so good because you have to clearly mention logN. Yeah, you can use n, no problem in this, but not in. So this is not a medium category. Then this is an easy category. So uh, you have to build a approach which is in login because so I think the problem is pretty clear and yeah, good to go with the examples. So suppose we have to find this zero here. So you are clearly see this 0 and 4. So yeah, just like this. And if it is not found, means 3 is not there in any. So we are written with what? Uh, array. So let me give you a hint. So if you go with the brute force, then how how we think? So you simply run a loop which take of n time, and you simply search it. Where is this element? If you don't found, you search. If it is there, you break and return that index. And if it is not found, then you simply return -1. Yeah, simple approach. We go often. But I tell you, this is not optimized. So how we optimize it? So let's discuss. What I did first. I go with the binary search approach. Okay. Uh, not think about code, just think approach. Because I also not first time when I did this problem, I'm not going to the coding way. I just think how I can approach this. So first I found, sorry, not thinking this target now. Just take this array 4, 5, 6, 7, 0, 1, 2. Now always try to find if you okay. So what I did here, I go with the approach. If I found a minimum value, so let's suppose how we know that this element is minimum. So you can see a pattern. Minimum element always less than its neighbor, because you can see if you consider one. Suppose I'm dumb, I'm not, I don't know anything. I consider one, but I have an algorithm. So I always tell this: your neighbor should be greater than you. So is it true? Sorry, not greater. Yeah, greater. Sorry. Your neighbor should be always greater than you. So neighbor is this also and this also. Is it true? Zero is greater than one. No. So that's why if I am dumb also, I don't know anything. Then also my algorithm makes me in correct direction. So that's a code only. You have to give the direction and your code works. Oh, so let's. I have to write too many times. So let's see here. Now I consider zero. I am also dumb here. I don't know zero is less than or not. So I am dumb. I totally dumb. I don't know anything in the world. So I go with my algorithm. Is my neighbor is smaller than me? So now I'm getting sorry, not smaller. Why I'm taking? It's my neighbor is greater than me. So is it true? Yeah, it's true. So my minimum element is zero, and always you find minimum element like this. You can see any example. Their neighbor, their neighbor are not uh, what follow this algorithm. So why I'm considering minimum element? Now see, now I check a condition that my target value is, because my array is sorted now. So if it is greater than, let's suppose, uh, if it is greater than my last integer, then I don't consider this part. I go with this part, because if it is not greater than the last element, then it's obvious, then it's not greater than the entire element. Because I have a good example that my teacher gave. If you found the highest height of a boy, so and compare with the suppose in any uh, suppose uh, you have a 10 rows and sorry, 10 rows, 10 rows of boys, and a simple example that is it greater than that height or not. So I'm if is it not a bad thing that I am consider uh, go with one? I take the row and what I just put out I just put I just put out the highest height of a boy of that row and always compare that sample example. So yeah, if it is highest, then if it is height is high, if its height is greater than that boy, then obviously it's greater height than the entire row. So I'm going with that technique. Yeah, it's not sound good, but if I'm good, then you get the point what I'm telling. Also, if you don't understand in one way, then it's okay. It's not a big thing that I'm telling. It's just consider a highest element and Yeah, and go with it. So if it is not greater than this element, then I am damn sure that this part is not considered anymore. So yeah, now my array is again small, and I compare, and and then the thing is very simple. You apply binary search and you are good to go. So how I can approach this minimum element in my code, because I have to follow this login. So I have to search minimum element with login. So how? So let's see. You got an idea. Don't consider it code now. Just think when you have to visualize this. You find one minimum element from there, and now you compare. Why I am considering minimum element? Because if you see this 4, 5, 6, 7, 0, 1, 2, if this array and this array are sorted, so binary search will be applied in these two half. That's why I'm considering minimum element. Minimum element is the breaking point. So I consider that index. Always I get a what? Always I got a index from there to this half, and minus of this, just one minus, and this two parts are sorted. So binary search, what binary search existence of sorted array. If there is sorted array, then binary search exists. Otherwise, don't. So let's see on code. Yeah, now it's interesting part. Let me clear my. Okay, don't save it because my handwriting are too bad. So let's see how we approach. So let left, let right. While left is less than right. Hmm. If norms of sorry, I have to binary search middle. Let me raise equals to. I tell you, don't use method floor. If you are using, then it's okay. But I tell you a better technique. Yeah, this one, pipe. It always take your value to what integer. Cool now. Hmm. Nums of mid. Yeah. Now I'm comparing like this. Nums of mid is greater than. No, not greater. Less than. Because I have to consider less, less, less. So nums length minus one. So right is equals to mid as this one. Now I have to console and give you a overview what's there. Yeah, we are getting 4. So let's try run first. What's happening here? So in the dry run, because this is the main part. Otherwise, everything is okay. Uh, so my left is now 0, and right is now my right is let's suppose what's the length? 1, 2, 3, 4, 5, 6, 7, 6. Okay, 0 is less than 6, true. It's going in the loop. Let me, well, yeah. Hmm. 0 is less than, it's going in the loop. Middle value of 3. So now mid is 3. So nums of 3, 0, 1, 2, 3, 7. 7 is less than is equals to this? No. So my left become mid plus 1 because 7 is not less than now. So my left is mid plus 1. Mid plus 1 what? 3 plus 1, 4. Sorry, why am my left is now 4, right is 6. Okay. Again, I just go. Is my left is less than right? Yeah, it's true. It's going to the loop. 6 plus 4, 10. So it's become 5. 0, 1, 2, 3, 4, 5. Nums of 5. 1 is less than 2. Yeah. So now my right become mid. So mid is 5. So right become 5. Are you go with this now? Now right become mid. That's right. Is it my left is less than right? Yeah, 100%. Now my mid. So 5 plus 4, 9. And if it is low value, so 4. So mid is become 4. This is dustbin. Not dustbin. Garbage. Now my mids become 4. In my mid is less than is equals to 2. 0 is less than 2 now. Yeah, 100%. Hmm. Okay. Yeah, 100%. So my right become 4 because mid. And is it left is less than is equal to no. So my loop is end and we are getting with the left. That's why I'm not using is equals to, because if I use is equals to, then it's again go in this loop. And because you you see the algorithm, right is equals to mid. So my right is not changing. Uh, because if I consider, so let's see the how, what the ending part. 4 plus 4 is 8. Then again we got 4. So it's repeating. So again we go. So let's see what happened if I use is equals to here. Left is 4, right is 4, mid become 4 after calculating you. Left plus right by 2. Yeah, obviously we got 4. Then we are going in this if condition because what I'm using here, mid is less than is equals to. So obviously, if its first condition is true, then this also become true. Now right become mid. Again loop start. Again loop start. Again loop start. Loop start. It's go in the infinity. So we are uh, we are deep in the loop, just like black hole. We are going and going in the loop. So we get an error of time limit exceed infinite loop, whatever you consider. So that's why I'm not using is equals to here. Yeah, always try run if you are not able to visualize it because dry run is the main thing. Otherwise, you know what I'm telling. So now I got my index. So now what? Now I'm checking. What I'm checking? If my target is greater than is greater is equals to, if my target is greater than is equals to norms and function, already it's too big video. I have to consider fast. So uh, uh return a helper function. This is a helper function. I just what I I just wrote in sometimes searching what I have to pass here. Just put left norms dot length -1 norms and target. else one else simple return 0. We are starting that first part because if it's not there, then obviously it is in there, and if it is also not in there, then obviously it is not anywhere. So left -1. Why I'm using -1? Because I consider this hub in this section, so it's not going to the valid way to compare again this. Yeah, you got it. Hmm. Okay. Yeah. Let's build our searching function. Once so left, right, norms, target. If so, let's see if norms of left is less than. So now it's simple. It's totally a binary search thing that mean is equals to -1. Why I'm using -1? Because if I don't found anything, not mean, let value -1. If I don't found anywhere anything, then just return that. Hmm. Hmm. While left is less than is equals to right. Now I'm using is equals to uh, mm, because now it's their searching thing. That's why I have a power to break my loop. That's why. Uh, what if sorry made hmm, f plus right if nums of mid is equal to target, then simply plus plus what uh, value is equals to mid break as if norms of mid is less than target. If it is less than, then increase your left value because anyhow you have to go with that level. That's why binary search, now it's simple. You have to just remove one half because your array is already sorted. So why you have to consider again and again? Compare with I told you that example. 10 rows. Just consider the highest height of boy and compare with that sample. So you don't have to go each individually to check the height. It's a seriously, it's a lengthy process, and also I'm not thinking that optimized way. Just consider one highest boy among them, 10 rows, and compare with that. If it is if it is not higher than that boy, then it is not higher than the entire row. I think you got this. Yeah, question. And symbol, if it is greater, if someone is faster, then break him. If it is someone is slower, then push him. It's simple life rule. Right is equals to made minus one. Yeah, you are taking life lesson from me. Who? Uh, return value. Now let's run it. Okay, we are waiting. Why I'm getting this? Hmm. Let me see what I'm missing here. Hmm. Hmm. Oh, if numbers of target, uh, I'm getting error. Yeah, I knew it. Hmm. Should we more optimize it? Let's see first what's the runtime. Okay, 60. Yeah, we are also submitting it. Mhm. Good, good, good. What I'm telling, there is one optimization. If target is equals to norms or left, then simply return left. Yeah, I should this work. Uh, yeah, don't use else because already return is there. Yeah. Hope this works. It took more time now. It took higher runtime. I don't know why. So don't see this. Yeah. Uh, so I tell you now, it's a simple approach. Not so just thinking about that. This is a binary search. This thing, what I everything going because this pattern you will see everywhere. Why I'm using is equals to here because now it's searching thing. So you have to consider that last element also. That's why think it like that. But in this, I told you in dry run that if you go like this, then we are not updating the right now. That's right. So just learn, just visualize this approach. Find the minimum element and break the array in two parts and apply binary search. Simple. And these things you are thinking that you have to learn this while left, right. No, I don't. I also don't. So why you have to learn? This is just practice thing. If you are if your thinking is good, then no one can stop. Just simple. Simple. Just go with this one way. If your thinking process is greater than your code, then you are in the right path. Because code you got in chat GPT also. Open AI source. You know that thing. But thinking process is not you got from chat GPT also. So yeah, just think that otherwise it's a simple approach. There is one solution also in recursion form, but I go with the loop thing because I like it. That's right. Yeah, and also loop is very friendly with beginner, not beginners. Loop is good than recursion. Hmm. So let me stop it because there is nothing to tell anymore. Yeah, it's simple. This searching function you already know. You have to just think this approach. You have to find mid element. And also one more thing, it's opposite. Just consider the peak element. And but I think yeah, peak element and just consider if my element is greater. If my element, no, you are stuck in that. Yeah, that's why my approach is best. Hmm. Because after this part, there will be a one chance of this part. But after this part, how we consider? Sorry. So let's see. So stop my recording. Okay, now Merry Christmas to everyone. Today is Christmas. So Hope you enjoy it and also like this problem for Christmas. And also share it if you like this the approach. If you like the approach of login, because this is a simple way to teach. And also dry run if you not good to go. And also if you find any difficulties anywhere, because it's uploaded in YouTube on YouTube. So just comment below. I'll answer it. Also share with your friends. Why are you waiting? And give a subscribe, please. Because if it's going good, then I'll post a real video with scratch. And I will tell you a thing that I have suffered in interview that you are not. So let me ask you one question. Uh, what is tree shaking? I tell you now, you what is tree shaking? If anyone from interviewer asks this, then what your expression there? I also faced issue, but I'll tell you these things. If you comment below, that's why I tell you if you comment, then I definitely answer it. If I got if I see, because in Saturday Sunday I will definitely reply each and every comment. So please like it, share it, subscribe it. Bye. Take care. Enjoy it. Merry Christmas. Bye.